This micro lecture is going to go over about two things. And first is going to be organism relationships in terms of the trophic pyramid. And the next one is going to be relationships in terms of how organisms relate with each other. I definitely would say you want to take good notes on the lecture portion. I'll do the best I can in a short video. Let's see how we do. How do energy pyramids illustrate relationships? So you might remember we had the food chains. Okay, so imagine each one of these different levels is a different link in a food chain, and it always goes up. Energy is always transferring up. Now, we also had food webs. Now, if you wanted to rank the food web from lowest to highest, this is going to be the same kind of thing, where there are going to be more organisms on the bottom of the food pyramid, i.e. kind of the base of the food web, and it's going to go fewer and fewer as they go up. And this is going to be true. If you just look around in nature, you're going to see mostly plants. It's mostly plants. Earth is green. And then if you were to look around the different animals, if you did a net or something, you caught all the different animals you could, most of them are going to be primary consumers. They're going to be eating plants. They're going to be eating fungi. They're going to be scraping algae off of the things. Secondary consumers like mice and lizards are going to be a lot less common in the ecosystem. You're not going to find a lot of small predators. And then things that eat predators are even less common. Now, a while back, I did mention that people don't eat seals. I was actually today in lecture, if you were there. People don't eat seals, and the why has to do with food pyramids. It has to do with how you actually need a lot of fish to make a single seal. So let's take a look at why that would work. We're going to use the seal as like the owl here. And to get this, you have to first go into some physics. That's the first law of thermodynamics. Energy cannot be created or destroyed, only transferred. So every transfer is going to have some inefficiency. That's the second law of thermodynamics. It's called entropy. What it means is every time you transfer energy, some is going to be lost as heat or as waste. So think about those, let's look down those primary producers. They're going to take in solar energy from the sun. Now, they're not going to use all the sun's energy. Some will be given off as heat. Some will be given off as just excess energy and not really usable. And some is going to be converted into forms that we can't use. As primary consumers are going to eat those, a lot of it is going to be taken off as feces. A lot of plant parts are not edible. If you've ever tried a full vegetarian diet, you're going to find out there's a lot of not edible plant parts. You're going to be throwing them away or visiting the bathroom a lot. Primary consumers do not eat, and most of the food, they don't get a lot of energy. Think about the last time you had a large salad, how soon you were hungry again. You're not getting all that energy from there. And then secondary consumers are going to eat a lot of primary consumers, but they're not going to eat things like the shells of those insects or the wings. So there's going to be a lot of undigested food. And again, things like mice are going to be giving off a lot of energy as heat, and that heat cannot be used by tertiary consumers. So the owl here cannot use the heat given off by the mouse as its own energy. So there's energy loss every phase, and there's biomass lost at every transfer. So that means the transfers get smaller, smaller, and smaller. So why don't people eat seals? Why don't we farm seals? Why do we farm things like cows and pigs? Well, cows and pigs are primary consumers. If you had to keep a seal fed, you would have to get that seal fed by fish. And those are medium-sized fish that are eating smaller fish, and those smaller fish are eating plankton. So in order to feed a single seal, you need 1 kilogram of seal meat, would need 10 kilograms of fish meat, which would need 100 kilograms of small fish meat, which would need 1,000 kilograms of primary producers. This is called the rule of 10%. It's not a really accurate rule, but it's an easy way of thinking it. Whereas if you were eating a cow, you would want a kilogram of cow meat, basically a 2.2 pound steak, not bad, is going to require 10 kilograms of corn or grass. And that's a much more efficient way of using your ecosystem. So we tend to live lower on the food pyramid. If we live lower on the food pyramid, we require less energy from the ecosystem. All right, moving on to symbiotic relationships. So you've probably heard symbiosis and you think, okay, these are two organisms. They love each other. They're basically married. They get along great. That's not what that means. Symbiosis just means living together. Sym means together. Biosis means living. So it's just together living. And there are multiple different types of symbiotic relations. We're going to cover a little graph of this on the board. There is another one of my videos. If you look in for ecological relationships, I covered this at a higher level, but it's still pretty darn good. Anyway, first off, symbiotic relationship is a plus plus. and that's mutualism. This is where both organisms benefit. The anemone here provides a clownfish with protection. The clownfish provides the anemone nutrients and scares off potential predators and cleans parasites. So both benefit. It's a plus-plus relationship. That's a mutualism. Then we have commensalism. It's a plus-zero relationship. So one organism gets a benefit and the other organism gets, well, nothing. So I got a lot of tree frogs in my garden, and they love my plants. They love hopping around on my pumpkins. Okay, great. What does a pumpkin benefit? Nothing. It's a zero. Tree frog gets habitat, gets protection. It gets a plus. Lichens living on trees are my favorite example of this. The tree doesn't care how many lichens are there, but if you got rid of all the trees, the lichens would instantly vanish because they need the trees. So they get the plus, and the tree gets nothing. Parasitism or predation or herbivory, I want to put herbivory on there too. One organism is harmed and the other benefits. So an owl eating a mouse, well, that's a predator. You have lice on that owl that are eating its feathers and making it quite a bit ill. Now those are going to be your parasites. The mouse eating grains of seed, that's going to technically be predation. Predation's when you eat the whole thing. Parasitism is when you eat part of the thing. Herbivory is when you eat not the whole thing, not a seed, but you eat part of a plant. That's herbivory. And we're not going to get into the nuances of that in class. As a lecture, yes, but on the test, no. So here's the how of it. And you really only need to memorize half of this. A benefit or plus is mutualism. A benefit and zero, or benefit neutral, is commensalism. They live together and one benefits. And a benefit and harm is parasitism, predation, or herbivory. And then you're going to look and see that commensalism shown there. You got another predation and parasitism down here. You got amensalism. Okay, what's amensalism? It just means neutral, really. Neutralism is neutral. Amensalism is neutral and harm. We didn't get into that. There are not a lot of examples. One you could use is you have a certain type of fish called a goatfish. And what it does is it scavenges around at the bottom and stirs up the sediment. And it makes the water very cloudy. When it makes the water cloudy, it has a negative effect on things like cod that you need to see in the water. So a negative effect on the cod, and the cod has no effect on the goatfish. So that's an example of amensalism. Again, we're not going to be testing that. It's kind of a fun one to know, but not a lot of good examples. Organisms are sorted into trophic levels of an energy pyramid. Energy can be transferred in trophic relationships. Symbiotic relationships are formed when two species interact closely and can be beneficial, harmful, or neutral to one organism involved. Oh yes, you may have seen competition. We're going to cover that somewhere else.